Hey there, algebraizers. It is time for a new and one of the best chapters of your mathematical career. In this chapter, we're going to talk about factoring, and specifically in this section, we're going to talk about what factors are. But the reason this is so important is this is your innate ability to pull the components out of a greater thing. So when you think about maybe when you listen to music and you hear all these instruments happening at the same time, factoring is the ability to pull out the guitar and the bass and the piano and what the drum is doing. And the same thing is happening when we look at mathematical problems, or we look at chemistry, or we look at people's health. This big idea of pulling things out of a bigger issue is what factoring is all about. And when we practice it in math, we can apply it to all sorts of things in the real world. So we're enhancing our factoring, our separating skills. So in this lesson, we're specifically talking about what is called prime factorization of numbers and finding the greatest common factor in a monomial. Well, what this looks like is whole numbers are the product of other numbers, and a number is divisible by its factors. So when we think of the number 12, it has factors of, well, 1 times 12 is 12. 1 and 12 are factors. Well, when we think about 12 is really also 2 times 6, or 3 times 4, or 1 times 4 times 3, or 2 times 2 times 3. All right, so there's all these different numbers that can be multiplied together to get the number 12. When we talk about a prime factorization, what that means is to break a number down into only prime numbers. So only of all these different factors of 12, this is the prime factorization because 2 is a prime number and 3 is a prime number. And really what we're saying is there are 2 2's, or 2 to the second power. All right, 4 times 3. So you can take a look at the text here. Prime factors can be written in any order, and except for changes in the order, there's only one way to write the prime factorization of a number, right? So no matter what number we have, there's only one way to do the prime factorization of it. Prime number has exactly 2 factors, itself and 1. So like the number 2, the only 2 numbers multiplied together are 2 and 1. The number 1 is not a prime factor because it only has one factor, 1 times 1. Just a little bit of mathiness there. Okay, so there's 2 methods to do prime factorization. Method 1, if we look at the number 98, you do what's called a tree, a factor tree, and we break it down. All right, well, 98 is an even number, so 2 goes into 98 49 times. All right, so 2 is prime. And then 49, let me think, 49 is 7 times 7. All right, so I've got 2, 7, and 7, or 2 times 7 squared. The other method is called a ladder, which I've never used, but it works the same way. But 2 goes into 98 again, 49 times. And then 49, what are your factors? Well, 7. That relieves 7. And again, you get the same 3 numbers in this fashion, right? But primarily, I've seen prime factorization done with a factor tree. And again, in simplified form, the prime factorization of 98 is 2 times 7 times 7, or what we would say, the 2 factors are 2 and 7 squared. What I would like you to do is, I would suggest using the tree, is try factoring these 2 numbers. Go ahead, pause the video, and when you're ready, come on back. Okay, boom, you're back. Let's see what you came up with. Factors of 40 and factors of 33. Of course, my factors of 40 are 2 times 2 times 2 times 5. Pause there. Of course, the phone rings right during the recording. So again, 40 is really 3 factors of 2, which means 2 cubed, times 5. And when I do 33, well, there's only 2 numbers that multiply together to be 33, and that's 3 and 11. So there's my prime factorization of 33. Same thing here. Pause the video, try these problems. Boom, welcome back. What'd you come up with for 49? Well, again, it's 7 times 7, or 7 squared. And 19 is already a prime number, so the only factors are 1 and 19. go ahead and try these 6 problems from your worksheet. And then at the very end, after we've gone through this entire exercise, I'll show you the answers and you can see which ones you did correctly and which ones we need to talk about in class. All right, you've tried those 6 problems. Now, let's talk about the greatest common factor. The greatest common factor is the number shared, the greatest number shared between 2 other numbers. Well, what does this mean? So let's say I have the numbers 12 and 32. Well, my common factors, first of all, let's figure out all the factors of 12. 1, 2, 3, 4, 6, 12. These are all numbers that in some combination I can multiply together to get 12. The same is true of 32. 1, 2, 4, 8, 16, 32. Well, my common factors are 1, 2, and 4, and therefore the greatest common factor of both 12 and 32 is 4. Why is this important? Well, when you factor things out, come on in, when you factor things out, this is one way that we're going to take the greatest common factor out of a problem. So the first method to do this is list all the factors and then find the highest one between the two. So again, between 160, the greatest common factor is 20. You can take a look at this example or pause it. The second method is the one that I'm more familiar with, and Nicole is probably more familiar with it as well. It's when you have 2 numbers, you do a prime factorization. Okay, 26 is 2 and 13. 52 is 2 times 2 times 13. Therefore, the greatest common factor between both of these are the numbers 2 times 13, and that's 26. So the greatest common factor of 26 and 52 is 26. So I'd like you to try this one. So list the factors and find the greatest common factor of 12 and 16. Very good. Welcome back. Your greatest common factors, once you've listed them out, are 4. Okay, yeah, 4 goes into 12, 4 goes into 16. Try this problem, but with prime factorization. What prime numbers go into 15? What prime numbers go into 25? Survey says, well, 15 is 1 times 3 times 5. 25 is 1 times 5 times 5. What do they have in common? They both have a 1. They both have a 5. Multiply those together. The greatest common factor of 15 and 25 is 5. Again, if I'm going too fast, just pause the video, rewind it, speed me up, slow me down, whatever you need to do. All right, try these next problems. You have 8 more problems here, and then again, I'll show you the answers at the very end. All right, now that you've got those done, you can also find the greatest common factor of monomials, and this is the basic breakdown when we factor out polynomials, as we're trying to find common factors of things that have variables in them. It's a really cool process. So, for example, here, find the greatest common factor of 15x cubed and 9x squared. Well, again, really what I'm doing is prime factorization. I'm saying, all right, I've got 3, I've got 2 pairs of x's, so I've got 3 times x times x. So the greatest common factor of these 2 numbers is 3x squared. They both have a 3x squared in them. So in a way, I can actually divide that out of both of those numbers. Stay tuned for another exciting lesson. Let's try these. What's the greatest common factor of 8x squared and 7y to the third? Well, 8x squared is really 2 to the third times x squared, and this is 7 times y to the third. Wait a minute, there aren't any factors. Yeah, the greatest common factor of these 2 is just 1. They don't have anything else in common. So don't be surprised that they're going to test you to see if you understand that concept. If 2 terms contain the same variable raised to different powers, such as like a to the 4th and a to the 5th, the greatest common factor will be the variable raised to the lower power. So in my example, a to the 4th is the greatest common factor of both a to the 4th and a to the 5th. And that's true of numbers as well. All right, so I want you to try these next 2 problems. Find the greatest common factor. Pause the video. Welcome back. What'd you come up with? Well, here I've got 18 is 2 times 9. 3 times 3. 27 is 3 times 3 times 3. So I've got a pair of 3's, which is a 9. And I've got a pair of g's, which is g squared. So the greatest common factor is 9g squared. All right, am I going to, what do you think of this one? Do these things have anything in common? Right, yep, that's right. The greatest common factor of these two is 1. Welcome back. It is just a busy afternoon here at Seward High School. Nicole's working away over there. You guys are working hard, focused on your lecture. I can see it, Hannah. You're like, Mr. Rising, I got this down. Colin's high five in Sequoia. You got it down. Try these next problems, and actually there's a word problem here at the end, and I'll give you a little hint. On this word problem, the first thing you need to do is find the greatest common factor of both 36 and 28. The second thing you need to do is then divide 36 by that greatest common factor and 28 by the greatest common factor. And that will help you figure out how many photographs need to be in each row. All right, when you're done, I want you to pause the video, go to the next slide, and you can see the solutions. And then if you have any questions, you couldn't figure out how a problem was worked out, please bring it to class on Friday. I'll go back to that in a second. And then I've also posted a few more problems from the chapter. I want you to try these on your own. Again, some of these are very quick, but it's really important, and it will really help your multiplication, your times tables, and your dividing tables. Because if you do these a lot and you have your tables down, the whole thing gets so much easier. You guys have a great rest of your afternoon. Flag me if you need anything, and take care. Here's your solutions.